Okay, so today we'll be doing experiment number 5, which is design and simulation of an infrastructure based network and comparison of performance in static and mobility conditions. So this is the kind of network that you'd see when you have mobile devices connecting to an access point to access internet, let's say a Wi-Fi network or something. So in this experiment we will be having a total of 11 number of nodes basically in a 1000 cross 1000 square meter area. We will have two set of nodes. One is 1 2 3 4 and 5, which will be connected to an access point. Here number 5, node number 5 is the access point, and the SSID for that access point is etc1. The rest of the nodes, that means 5 to 11, will be connected to etc2. They will be basically, the AP will be node number 11 and the SSID is etc2. Okay, so this 5 and 11 will be used as access points. The scenario is like this. As I have already told you, 1000 cross 1000 square meter. Simulation time is around 300 seconds. Physical layer is 802.11 radio, which is again the same Wi-Fi. Two-ray ground reflection model is considered as the propagation model, considering this kind of networks are mostly in corridors, okay, that kind of area, mostly in indoor areas. Even in outdoor they are limited to a short distance. That's why this model can be a good fit. Access points are, as we have already discussed, 5 and 11. Traffic is CBR, constant bit rate traffic will be there. Then mobility will be considering both the conditions. One is under the static conditions, the second is under random waypoint. The link delay is 20 millisecond, that is between the two access points, okay, and the link capacity is 100 Mbps, that is between the two access points 5 and 11. Operating frequency is respectively 2.24 GHz and 2.34 GHz. So let us start the experiment by placing the nodes. Okay, I'll just go to Qualnet, and here as you can see the terrain is more than what is actually required in the experiment. So I'll just go to tools, scenario properties, and then I'll go to terrain, and I'll reduce the x and y coordinates to 1000 and 1000 square meters respectively. Okay, then apply and OK. The next thing that we have to do is to place the mobile nodes basically. So here I'll go to devices tab and I'll get the this mobile phone icon is available. So I'll just put the first 5 nodes. I can arbitrarily place them anywhere. Okay, once I have placed these nodes, okay, I'll also bring the other set of nodes, okay, which is node number 6 to 11. So 6 7 8 9 10 11. So I have placed the 11 nodes here. The next thing is connecting these nodes to the wireless network. So I'll just, sorry, I think I have added an extra node. Yeah, so I'll select the first 5 nodes and I'll connect them to the through the wireless network. So I'll select all these nodes, and then here under the network components tab we can find the wireless network. So I'll just click on it and I'll place that wireless network here. Okay, next is I'll be again selecting the other set of nodes, okay, and I'll be placing another wireless network. I'll be connecting them basically through another wireless network. So I'll again go to the network components tab and I'll click on wireless network. I'll bring in it and I'll just click on the workspace, and as you can see they are all connected. Okay, so once we have connected all these nodes, next is we have to make some modifications in the wireless connectivity. If you see here in the manual, okay, the different procedure are given. We have successfully placed all the nodes, as you can see here. Okay, next is connecting them. Okay, next is making some changes in the wireless network basically. Okay, so we'll change a few parameters in the physical layer, MAC layer, etc. Okay, so let me do that. So we'll just click on here on the wireless network, then we'll go into the properties. Okay, so I'll go into the properties. So physical layer will be as it is, the radio type will be 802.11 radio. Okay, MAC layer will be 802.11. Okay, station association type we will change it to dynamic. Okay, then SSID we will be setting as etc1 for the first set of nodes. Okay, another thing that we are going to change is station scan type. We'll make it active. Apply and then OK. So this is the first set of node. Similarly for the second set of nodes, again we'll click on the wireless network and we'll go to the properties. So again physical layer is 802.11b radio. Okay, so MAC layer, we'll go to MAC layer and station association type is dynamic. SSID we will set as etc2. Station scan type is active. Okay, just apply and then OK. The next thing that we will be doing is we will be connecting the two access points. Okay, the node number 5 and 6, 5 and 11 are the access points. So we'll first set them as access points and then we'll connect them through an interconnect line. So let me click on 5, then I'll go to properties. Here I'll go to interfaces, I'll expand it. Here you can see MAC layer is there. I'll go to the MAC layer and there set as access point is set to no. I'll make it yes. So this will work as an access point there. I'll just click on apply and OK. Similarly, I'll do the same thing for node number 11. I'll go to properties, interfaces, interface 0, MAC layer. Okay, so access point, I'll set it as access point and I'll click on yes and then apply and OK. So since I have already set them as access point, next is linking them. Okay, so for that I'll go to the links tab. Okay, and then I'll click on this link icon. Okay, I'll click on 5, I'll hold on to the mouse button and I'll just drag to 11. Okay, so now they are connected. There are few parameters of that link as we have already discussed. It is a 100 Mbps 20 millisecond kind of link. Okay, which means the bandwidth is 100 Mbps and the delay is 20 milliseconds. So let us specify this same in the link. So I'll go to the properties of this link. Then next is I'll set the propagation delay to 20 milliseconds and the bandwidth to 100 Mbps. Apply and then OK. So they are connected now. Next is we have to set the CBR connection between the different nodes. Okay, so CBR traffic we have to apply. For that we have to actually refer to this table that was provided. So there's a link between 1 to 2, 3 to 4, 4 to 8, 7 to 9, 2 to 10 and 1 to 8 respectively. So for that we'll have to go to the applications tab where the CBR application is present. Then we'll connect 1 to 2. Okay, then 3 to 4, 3 to 4, then 4 to 8, 4 to 8, then 7 to 9, 7 to 9, yeah, and then 2 to 10. Okay, and then 1 to 8 respectively. Next thing is we have to specify the initial and the final time in seconds. Okay, so for 1 to 2 the transmission starts at 1 second and ends at 250 seconds. So let me just click there on that link. This is the link. We'll go to the properties. Okay, then once start time is 1 second, end time is 250 seconds. Just apply and OK. Similarly, for 3 to 4 it's 50 to 300. 3 to 4, so this is the link between 3 to 4. I'll go to the properties. Okay, so start time is 50 and the end time is 300 seconds. Just apply and OK. Then for 4 to 8 it is 75 to, it seems 0 is there. However, we'll set it to, the final value will be always higher than the initial value, so we'll set it to somewhere around 300. That will be better. Okay, so 4 to 8, this is the link 4 to 8. I'll go to properties, so I'll make it 75 to 300. Next is 7 to 9, 10 to 300. 7 to 9, okay, so this is again start time is 10 to 300. Okay, so it is 10, it starts at 10 and goes up to 300 seconds. Apply OK. Then 2 to 10 is 5 to 275. 2 to 10 is 5 to 275. Accordingly, we'll modify it. Similarly, for 1 to 8, it is 15 to 275. 1 to 8. Properties 15 to 275. Okay, so we have already specified all the parameters. Next thing is we have to actually simulate this network. We have to save and then we have to simulate this network, and we have to analyze the different parameters. Also, I'll go to just save as, I'll save it as infrastructure underscore static, because no mobility has been defined till now. Just save it. Okay, so once we have saved it, we can actually run the simulation. So for that, I'll go to tools and then I'll go to run simulation. Okay, and then I click on the play icon. So as you can see, data transmission is going on. Okay, so we can visualize the different graphs here, such as throughputs, etc. So for that, I'll click on that icon. So you can see first packet sent, last packet sent. The timings are given in seconds when the first or the last packets were sent. Throughputs in bits is provided. These are all for the clients. Similarly, for the servers, similar information is available. So if we want to, let's say, view the how the UDP or TCP connection has actually worked in this network, you can see the same thing are visible here. Then in the MAC layer, we can see the DCA protocol, which is normally followed by IEEE 802.11. Some CTS, RTS packets are sent. Okay, clear to send. All those kind of packets are sent. Request to send. So these packets you can see here, how many packets were sent. Okay. Some unicast broadcast packets are also sent through the network. Same can be visualized here. Okay. So again, this was for the static scenario. We have to now execute the dynamic scenario. So for that, I'll again go back to the architect mode, and then I'll click on this icon to switch to design mode. Okay. So then you can see in the manual, node 4, 5 and 8, we have to set the movement to random waypoint. Okay, so now we will simulate the dynamic scenario where the nodes will be mobile. For that, we will be choosing node number 4, node number 8, and I am also choosing node number let's say 9. Okay, the reason is that like why I am not choosing node number 5 is that both node 5 and 11 are connected through a wired network, and it's in best interest that they should not be mobile basically. Okay, so after selecting these nodes, okay, we can go to properties, and then in the node configuration we can choose the mobility model as random waypoint. Okay, so I'll just set the pause time to 0 second because I don't want my nodes to stay at one location at any time. The minimum speed and the maximum speed we can actually set. I'm setting it from 3 meter per second to, let's say, 5 meter per second. Okay, so we are free to choose any speed which would actually match with the realistic conditions. Okay, after doing all these things, let us save this file. So I'll save it as infra. Since the previous one was static, I'll save it as dynamic. Okay, so once I have saved it, we can now simulate it. I'll go to run simulation. Okay, and then I can run it. Okay, so one can see that now the nodes are moving. Okay, so one more thing I would like to tell you. Let's go switch back to the design mode. So let's say you want your nodes to stay at a particular area. You don't want your nodes to move actually from beyond a particular area. Then you can use these flags. In the other component, you can see these mobility flags are there. You can just put them near these nodes. Okay, like let's say I am putting some flags like this. Okay, so that way I am limiting the movement of node 4 within that the area enclosed by those flags. Okay, so now let me just save it. Okay, and then let me run the simulation again. So now you can see the node is was moving within the flags basically. Okay, so once the simulation is over, we can now analyze the statistics of the particular scenario. These are for the CBR client, these are for the CBR server. Okay, now the next thing that we have to do is we have to compare both the scenarios, the static scenario as well as the dynamic scenario. For that we will have to go to the file system, and we have to just expand this one so that we can identify the different files basically. So we'll have to add the files for the two scenarios. Okay, so we'll have to click on add, then we have to go to the scenarios. There we have the infra, structure, dynamic and static, both are available. I'll just choose one by one. Static I have chosen, and dynamic now I'll choose. So I'll choose the two scenarios. I'll just expand them. For the static and dynamic scenario, I'll just expand them. I'll select their start files. Okay, and then I'll just right click on it and I'll click on analyze. Okay, so here you can see the comparison between the two between the static and the dynamic conditions, or the mobility conditions. Static and the mobility conditions, when the node are moving, you can see the average end-to-end delay is increasing, right? Similarly, lot of other parameters you can view, such as in the MAC layer you can see the number of CTS packets, RTS packets sent have dramatically increased for the mobility scenario. Okay, the average end-to-end delay has also increased. So these are the things you can note. Okay, so these are the differences between the static and the dynamic or the mobile scenario. So this is how you have to perform this experiment. If you want to save certain graphs, okay, then we can do that. So let's say I want to save this graph. I'll have to go to file and then export, okay, then as image, okay, then you can provide a name for that particular file and it will be saved. Okay, you can do this for all the different graphs. So this was all about this experiment. Let me end the video here.